Okay, so this week will mark the end of module 2. All projects, all 4 projects from project 5 until 8 are required to be submitted. It's due this Sunday. So today we are going to go through project 8 as well as going through chapter 8. Chapter 8 is talking about vulnerability mapping. So let's see what's this. In terms of object, constructing use case and misuse cases for system, how to document the system and identify security issues, mapping system vulnerability according to design, identifying where mitigation and security techniques are needed from the design perspective, and finalizing the complete business specification of the system. So, use case construction and extensions. The first step in moving from a listing of system requirement to an actualized and deployed system is the process of use case mapping. The use case is translation of functional requirement into a visual map of activity that details the steps of arranging at a measurable system outcome in more general and explicit fashion. So technically, what's this? Now we already talked about the the development system life cycle, where we said people will sit down, they will tell you what they want, you will write what they want. Now, what they want is the requirement, is the basics of the requirement. So technically, they want a system where someone can log in and go ahead and can see so and so on. So on your part to list the requirement, to create a long list of requirements that someone can use it and put it into activity. So technically, a programmer do not know what to put until he have a list. So you need to put a web page that has a login and a password, da 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 da. Based on that, the programmer will start actually working to deploy the system and complete the system. So a use of case is a translation of functional requirement into a visual map of activity that detail the steps of arranging at measurable system outcome in more general and explicit fashion. So technically was this. After listing, and before we start technically typing the program, there's the flow chart. The flow chart will show us, how things will move along in a visual way that we can see if and so on, and how we can have it. So if a login is accurate, what's going to happen? If it's not inaccurate, what's going to happen? All of that in a map. Okay. So use involve 3 primary components: an actor, a procedure, and association. An actor is a person, external system, or an entity that play a role of in a performance of a functional task described in the use case. So technically, a user is an actor, a user going to log in into a system. So now, and the actor over here is the user. A procedure is the step performed to achieve the outcome of the system specified by the functional requirement. So the procedure is the login, or the signing in is the procedures over here. Association is the relationship between the actor and the procedure. For actors and procedure, this is represented by directional arrow, specified the instantiations of the next step in the process for the system. So we have someone will log in. If that information is matching, then he will go to the home page or the login page or my account page. If it's not, then it will be asked to reprompt, it will be prompt to enter the information again, just like this. So user logs into the system. So we have an end user, a database over here, which is our actors. We have the relationship and the process. User request page without login, system request credentials, system profile site credentials, and system deliver pages. All of these information is how we can use something. Managing misuse. This is an attempt to elicit security requirement by considering what a malicious actor could do within the context of the system. And over here is the malicious actor. So if a hacker pretending to be a user, what's going to happen? We have something called misuse management method, which is done by first keeping all of the actors in your use case to the left of the procedures and keeping the procedures in the middle of the diagram. Draw a dotted line between, through the middle of the procedures to separate the normal operating case from the, diagram of malicious attack on the system. The left side will retain the use case properties and information. The right side will contain the analysis of security needed and the procedures extended or extensions necessary to round out the functional in the case used to manage an attack. In the next slide, we will have an example. So technically, we have here an attacker, we have here a user that's going to show up what we should have and what we should not have, what we should see and what we should not see. That's what the misuse management method. After the individual use case has been completed and the misuse information has been added to the diagram, it is possible to start mapping the entire system. The easiest way to do this is to create a new use case overview diagram and add the central functionality defined in each of the individual cases. Sequence diagram and class analysis. A sequence diagram is a detailed breakdown of communication that will occur between actors and system object or component. A sequence diagram is most compatible with object-oriented system because it always relatively straightforward mapping from use cases by applying object models to instantation. A class is a template for a behavior and verbal use. An object is the instantiation of this template. There are several types of classes that will be determined in the sequence, like an entity, a boundary, and a control. An entity class is broadly a storage class. The object it generates are the housing of the most of the data in the system. Boundary is the primary responsible handling interaction between the actor and the system. Control is the coordinator for the system. These classes, insulates entity classes from hanging or changing, businesses, rules, and policies, effectively modularizing the system to a degree. So that's the sequence diagram process step. So choose a single case use, write each process for the use in detail, specify the boundary, single control, entity, specify the control, align the use cases steps next to the row, refine your classes and refine your classes for any functionality that's too complex for single class. And technically that's what we are talking about. Data planning. The goal of data planning is to establish the database construction that will be needed to support the system being developed. One of the biggest problem is while developing any application or any system is most of the time, programmers and technical do not discuss anything about database. And when it comes to the requirement to the programmer, What's happened that the programmer do not know what's going on. There's no mentioning of a database, and now the programmer need to create a database based on his understanding of the requirement. So the goal of data planning is to establish a database constructed that will be needed to support the system being developed. An entity relation model, or EI model, is a relational diagram used to establish tables, attributes, and relationship within a system. The cardinality is a number of relationships that can occur from one table to another. Know your boundaries. There are several good restrictions for boundaries classes. A boundary class is not allowed to directly execute any input. A boundary class on the client machine is not allowed to devlog or contain privacy data that is not entered by the client or sent by the internal control class. The boundary class must authenticate the communication control class to which it is connected. A control class on the outside of the trust boundary should never be allowed to interface directly with the control class on the side of the trusted boundaries. A control class must authenticate the boundary class from which it receives the message. A control class must provide authentication to the boundary class to which it is communicating. A control class must evaluate or process input from boundaries class before directly executing any information coming from boundary class. A control class must provide authentication to any entity class from which it requires or requesting privacy data or mission critical data. A control class is not trusted, that is not trusted cannot directly communicate to any entity class that is trusted. All data members of the control class must be private or protected. Now let's talk about entity class. An entity class can devlog information only to control class. An entity class on a client machine may not directly access information inside the system trusted boundaries. An entity class may not communicate with the boundaries class. An entity class housing private, confidential, or mission critical data must authenticate the control class with which it is communicating. An entity class has the right to refuse the devlog information. Any entity class is not allowed to have a public data members. Communication activity and state diagram. A communication diagram is a calibration diagram and is an alternative view of the sequence diagram in which all of the interaction between the class are mapped as function call for the class. An activity diagram is a type of supported diagram in which the workflow of a use case is mapped out in a flowchart format with a well-defined starting point and clear ending point. A state diagram is model of the lifespan of an object within the system. Vulnerability mapping. The overall goal of performing vulnerability mapping is to determine the most likely location within the system to develop development where an attacker will strike. Most of the time going to be a login page, a search page, a search box. There's a lot of places. To start vulnerability mapping, identify the input location of the system, the internal communication, and the inter-process communication. The following basic classification system will work. V3, this is the highest level of vulnerability. V2 is the moderate level of vulnerability, and V1 is the lowest priority level of vulnerability. Complete business system specification. The specification for the system is now at its most detailed level for the business side of the system development. we have an executive summary of the system overview, similar to which is presented as the project overview for the case project, the collection of non-functional requirement, the collection of functional requirement and associated use cases, the sequence diagram constructed from the use cases, the use cases overview diagram, the class analysis diagram, the entity relation model. Optional to have an activity diagram, optional to have state diagrams and communication diagram. Then we have the vulnerability map attack service document, where saying where it most of the time going to hit. And this is the end of the project, or the summary. Now let's go ahead and start talking about project 8. Project 8 will require a download for a specific application. So let's go ahead to that project. So we are going to use a tool called Splunk. Splunk is a security tool. You need to go to the download page. You need to create an account, by the way. After you create an account, you go to that download page. You will download the Enterprise, Splunk Enterprise, the latest one. After you complete the installation, during the installation, it will ask you to have a username and password, the one that you just created and approved. Then it will open a page, a web browser, and you will go to localhost colons 8000, where you will see this Splunk. Then after you log in, now here is everything new. Here is the messed up over here, where you will have problems when you want to do the project. So let's go ahead and call the web page. And by the way, I was like working on it. I've completed the download. I completed the download. I already activated my account. So technically I reached over here, or technically after I log in. So technically you see here where we say adding a source data. Over here is where we add a source data. So let's go ahead and add the source data. Technically, you go to click on add data. Then you will say the method, you have a bunch of apps, or you go to monitor. When you go to the monitor, it will ask you from this list to where to click. So you are going to click on local performance monitoring. Local performance monitoring. I don't know where you said it, but performance data, it's different. So after we go here, and by the way, if you want to see it, it is over here, local performance monitoring. You see it over here? It's the same, but I think this is an old one, or my tool is different. So local performance monitoring, we will name it CPU, and the object going to be from here, processor information. So processor information. Then we are going to choose the percent processor time. So we will select percent time, and we will select total. Then we say next. Oh, I already have this. Let's put it number 1. I don't know if I have it. Search app. Let's see. Review. Submit. Start searching. And it will start searching information about your oh, we already started searching before even nothing found. That's not good. Let's go ahead and add more. So add more. Add more. Then we go to event locally. So local event logs collected from the machine, application system, and security. So application system security. And this is our start. Now we have information about the CPU and the event and so on. And you can see a lot of information about, start searching, let's see where we have installed. So technically we can say, technically I just installed the system, so we should have an event about installing the application. So we go to, I think, install, forget, yeah, let's say install. And that's over here, we have an install over here. So that's the project. You take 2 screenshots and you deliver it to me. Questions? Okay then. See you next week. Thank you, Derek.
Okay.